Okay, let's pull back the curtain on one of the most important yet kind of invisible pieces of tech that powers our entire online world. Seriously, it's the unsung hero that keeps your favorite websites from completely falling apart, and it's called a load balancer.
I mean, you have definitely been there. You're trying to snag concert tickets the second they go on sale. Or maybe you're grabbing that Black Friday deal, and then, boom, the site just freezes. It is so frustrating, right? Well, it happens for a very specific reason.
And the simple answer is just overload. That website server, which is really just a super powerful computer, is getting hammered with thousands, maybe even millions of requests all at the exact same time. It's like one person trying to answer a million phone calls at once. There's just no way it can keep up.
And this all leads us to the biggest problem for any successful website, the traffic jam. The minute you get popular, a single server just isn't going to cut it. It becomes a bottleneck, slowing everything to a crawl and, eventually, causing a total crash. Just try to picture it. Imagine all the website's traffic trying to squeeze through one single tiny door. That's exactly what one server is up against. So to handle that kind of scale, you don't just need more doors, you need a really smart way to manage who goes through which door and when.
And that is where our solution comes in. See, to handle all that traffic, websites use a whole bunch of servers. But you need something to direct the traffic intelligently. So let's meet the internet's own personal traffic cop.
This is a load balancer. It sits right there between you, the user, and all the website servers. Its entire job is to look at every single request coming in and intelligently decide which server is best equipped to handle it at that exact moment. This is what prevents any one server from getting totally overwhelmed, and that is the absolute key to reliability.
So how does it decide? Well, there are a few different strategies or algorithms it can use. The simplest and most straightforward one is called round robin. And really, you can just think of it as taking turns.
You know, the real beauty of this first method is its simplicity. The load balancer doesn't overthink things at all. It just hands out the incoming requests one by one to each server in the line. And when it gets to the end, it just loops right back to the beginning. Easy.
The whole process is just like dealing a deck of cards. The first request goes to server 1, the second, server 2, the third to server 3, and that fourth one, yep, it goes right back to the start. It's simple, it's predictable, and it makes sure everybody gets a turn.
But there's a trade-off, right? Round robin is incredibly easy to set up, but it has one huge blind spot. It just assumes every single server is equally powerful and that every single request is pretty much identical. And in the real world, that's almost never true.
So let's level up to a smarter approach. This next method is way more aware of what's actually happening on the servers. It's called the least connections algorithm.
Now, this is a much more dynamic strategy. Instead of just blindly handing out requests, the load balancer actually checks in with the servers first. It basically asks, hey, who's the least busy right now? And the new request goes to whichever server raises its hand.
It's exactly like choosing a checkout line at the grocery store. You don't just pick a random line, right? You glance over and you join the one with the fewest people. In this case, server 2 is the obvious choice. This makes sure that the work is distributed based on the actual current load.
This method is pretty much ideal for something like an e-commerce site. And why is that? Well, because a user who's just browsing pages is a really quick task for a server. But someone checking out with a full cart, that's a much longer, more intensive process. Least connections prevents those checkout servers from getting totally bogged down. Okay, but what if it's really important that a user keeps interacting with the same exact server over and over again? This is something called session persistence, and it's absolutely critical for things like online banking or, you guessed it, online shopping.
And here it is, that aha moment. Ever wondered how a website actually remembers what's in your shopping cart as you click from page to page? This is how. It's because the load balancer is making sure you're always talking to the one server that's holding onto your cart data.
The way it works is pretty clever. It takes your computer's unique address on the internet, its IP address, and it uses a math formula to assign it to one specific server. The results of that formula is always the same, so as long as you're browsing, you'll be stuck to your designated server, which keeps your session completely intact. So the trade-off here is all about consistency versus balance. You get that crucial session persistence, which is great, but what if one user is a power user who's creating a massive amount of traffic? Well, their assigned server could get totally overloaded while the others just sit there pretty much idle.
So as you can probably tell by now, there's no single best algorithm. It's really all about picking the right tool for the job, based on what your website or your app actually needs to do.
All right, let's recap real quick. For simple, uniform traffic, where every request is the same, round robin is a great, simple choice. For varied traffic, where tasks take different amounts of time, least connections is way better. And when you absolutely have to maintain a user's session data from one click to the next, IP hash is the way to go.
And honestly, we're just scratching the surface here. There are even more advanced strategies like weighted round robin, which lets you send more traffic to your more powerful servers and less to the weaker ones. And there's also least response time, which is even smarter. It sends your request to the server that is not just the least busy, but is also responding the fastest at that very moment.
So the most important thing to take away from all this is simple. Every single time you visit a major website, there is a load balancer working silently in the background, making millions of decisions every second just to keep your experience smooth. It really is the invisible backbone of a scalable and reliable internet.
Which, of course, leaves us with a pretty big final thought. As the internet gets even more complex, with all this new traffic from AI and billions of smart devices, how will these load balancing strategies need to evolve to keep up with the demand? What does the traffic cop of the future even look like?